Right. Hi, everyone. So today we're going to be talking about semantic segmentation on farms using UAVs. So this overarching presentation is part of the AI for Earth research grant with National Geographic and Microsoft, and I'm one of the persons taking part in this project. So just gonna go over a brief overview of kind of like what are the main problems that we are looking at for the project, which is just the first problem being determining plant health, multi-class semantic segmentation, which is our focus today, and determining water stress. So just to give a general idea, so in terms of determining plant health, essentially what we're doing is, since we bought a drone recently, the DJI Phantom, what we're going to be doing is we're going to use aerial images and take something called the NDVI, which is just helps to determine the plant health, and being able to kind of like using RGB images and trying to predict what is a plant health for those crops, right? Our focus today is going to be on the multi-class semantic segmentation, right? So essentially what that is we're going to take an aerial image of a farm, and we're just going to determine where the plants are, where the weeds are, and where the like background is, right? So that's going to be our focus today. And the other one is going to be determining water stress, and that is going to be done using some water sensors that we're going to take readings from a farm and take aerial images as well, and just trying to determine what is the water stress of the particular farm. But those are kind of like the first and third problem are kind of their own separate problems. But we do plan to kind of like use similar models that we're going to be discussing today for those other problems. But right, so let's get into what our focus is today. So since we actually only were able to get the drone recently, which is like on Friday, what we did in the meantime was we were looking at using an example data set. So that is called, it's based upon a data set from this paper, WeedNet. So essentially what it was a data set taken from, I think, a beet farm, I believe it was. And so they took aerial images of the farm, and they kind of like, so essentially what it has was, it had these crops, and then it had weeds. This is just this image here is just an example of the crops. And so the data that they presented actually, which is a little bit strange, but so they focused on near infrared, red, and NDVI. So those are the channels that they use to train their model. And they use a machine learning model, well, fully convolutional neural network known as Segment, and we'll discuss that later on. But yeah, so what I essentially had to do was, I kind of like combine those images and kind of use that to go about training our data set. So that is essentially the data set that we were using. And actually, when we tried to look around for like other data sets and stuff, since we're using the NDVI channel as well, for a few of our problems, it is actually not as easy to get that sort of data. So this data set was actually kind of like very, very helpful to go about training our models. So we're going to be looking at the different deep learning models that we have, right? So the first one I spoke about was Segment, which was used in the in this WeedNet paper. So essentially what Segment does, it has a kind of like, since we're doing semantic segmentation, we're going about labeling each individual pixel, right? So for example, in this picture here, we have like, a road, we have the sidewalks, we have trees and different things like that. So we want to label each individual pixel, right? And that's essentially what we'll be doing in this problem, right? So you see here, you have the image of the crops, and you have like the soil, which is considered in our case the background. So we want to know where the plants are, and well, this image doesn't have the weeds, but where the weeds are and stuff like that. So essentially what it does, it does some convolutions and does some upsampling there. This is actually a bit of a easier model to use as opposed to the next model we'll be speaking about, since it uses upsampling. It has less parameters and stuff that it has to go about training, but it still is a deep learning model. So it is still a bit more difficult to implement, for example, on like a drone. So as for instance, in this WeedNet model, well, WeedNet slash SegNet model, they actually use a Jetson, kind of like a Raspberry Pi, but it has like, I believe, like a GPU capability. So we may try and see what happens if we implement SegNet, but I believe that these deep learning models aren't as meant to be run on like a Raspberry Pi device just to go about like, testing the data and stuff. But yeah, so these are one of the models that I went about implemented and getting the results for. So the next one is Deep Lab V3. So this was actually, well, actually, I believe this one here was made by from some people at Google. I may be incorrect, but I know for sure the Deep Lab V3 one was one that was proposed by some people at Google. And so in this instance, they used something called HRS convolutions, which I believe is kind of like a better version of doing like transpose convolutions. I believe it's along those regards, because with the transpose convolutions, it's actually quite expensive to go about um, implementing those convolutions, because there are a lot of filters and stuff that you have to go about learning. And what they also do is they go about like they kind of do like I believe it's called like a pyramid pooling sort of method. So it's able to kind of like better understand what is going on in the image. And so this was a V3. And so this has been kind of like it has been widely used for a lot of different research papers. So whenever like people are talking about like proposing a new model, they normally kind of like benchmark it against Deep Lab V3. I believe there's also Deep Lab V3 Plus that was proposed later on as well, or it was in the same paper. But like that is another like a very popular machine learning model that is used a lot more now. So yeah, so that's another model that we went about going to use. And so the next one we looked at is UNet, which is a model I spoke about like a few months ago. I use it for like one of my problems. And so, but this one uses the transpose convolutions or deconvolutions. So it is quite expensive. And so like a model like Deep Lab actually is able to kind of like perform I believe much better than like say like UNet and SegNet on like a lot of like kind of like a multitude of different problems. So yeah, but like also we just want to make sure, and we kind of like using kind of like what is like state of the art model. So I also we also implemented UNet. So next we're going to be looking at the results that we've been getting so far. So say this example here, we have an image where it has some weeds and it has some plants or crops, right? And so this was a ground truth image here. But then we have SegNets, and this was based upon like 600 epochs. I believe it actually stopped kind of like improving results after like 400 epochs. But this was a kind of like the results that it was getting. And this was Deep Lab V3. This was based upon 50 epochs. I'm actually today I was going about trying to increase the amount of epochs and seeing what kind of difference we're getting. But it kind of appears so far that SegNet is kind of performing well. But I still need to make sure and go through the overall results after training this after a number of epochs and making sure that it's being trained well. But so far, we are getting some okay results. And we haven't implemented. We've been working with UNet, but we still have to go about training it and testing it on our data set. So hopefully we'll be getting those results soon enough. And so we also want to be comparing that against kind of like traditional approaches, because in the literature and stuff that we've been looking at, when it comes to like determining like multi-classification and stuff with crops, a lot of people have used things like support vector machines and random forests, right? Um, so we want to make sure and use those kind of traditional approaches also, because when we go about training these deep learning models and stuff, right, it's actually kind of expensive to go about training them. Like even though we have Google Cloud and stuff, like later on it does become a bit more tough to go about training, especially when we start increasing our data set and everything. But these like traditional approaches could be like, it doesn't need like a dedicated GPU and everything. It could help if it has a GPU, but like just having like, kind of strong CPU is still fine to use. So we've been looking at, using support vector machines, naive Bayes, and random forest. And we're hoping to get those results soon enough. And we also might want to look at using an approach when this paper is discussed where they exploited the fact that, crops and stuff are in a line and that weeds and stuff wouldn't be in like that kind of like straight line. So trying to exploit that sort of kind of like thing that is common in forests. And so yeah, that is essentially it. These are just my references. Yeah. So does anybody have any questions?
Yeah, thanks, Keanu. Couple of things. So have you started using the Azure resources we have for this work, or?
Yeah, so I plan to be using that soon. I just kind of like, I was just trying to get like, kind of like the basic models that we have so far. So we discussed it last week about how we have how we have access. So I want to start like kind of like implementing the code and stuff in Azure to go about training and stuff. But I just kind of just wanted to make sure that we kind of had like the code was actually running and everything. But we do have working code and stuff now. So yeah, I want to go about testing that on the Azure resources that we have access to.
Okay, and hopefully soon we'll get actual data from the drone. The other thing is you mentioned the Jetson Nano being used for some of the segment, I believe.
Yeah.
And if you want to try that out without purchasing, we have 2 Jetson Nanos that we use for 2 different projects. So if you need access to one,
okay.
I believe Rajiv also has one, right? Rajiv, you also have a Jetson, right?
Actually, that was Kevin's Jetson Nano, and I gave him back before I left. But I'm sure he would lend you guys if you asked him.
Well,
he's
no,
using it right now.
Yeah, well, we have 2. We have one. Kabir is using one, and
yeah,
Peter is using one. So we have access in case you want to try out anything with it.
Yeah, that could be something we could go about doing as well.
Okay, yeah, thanks, and nothing else for me. I'm glad to see progress is being made on the project. Thanks.
Mm-hmm.
Hey, Keanu, I just have a quick question. Did you guys look at using mass CNNs as well? Because they could also be used for segmentation, and they're fairly efficient too.
You mean the mask RCNN?
Yeah.
Okay, yeah. Michael, one person in our team had suggested that we go about doing that. So he actually he has experience working on that, so he is implementing that. So we'll be looking at what kind of results he began from it. So yeah, so it's something we're exploring as well.
Yeah, okay, sure. Because actually, I'm just interested in seeing how it performs compared to SegNet and UNet for this task.
Yeah, because I have seen I've seen like some like stuff about it, but I've never really seen it like people use it for like things like when I see those segmentation problems and stuff, I haven't really seen it there as much. So I guess it'll be interesting to see the type of results.
Same with me, because this type of stuff is SegNet is usually used, or UNet a lot more. I would think. Yeah, but give it a try. I think it could be cool too.
Okay. Yeah.
Good stuff though. Thanks.
Yeah. All right. Thanks. I think there were some questions in the chat.
I guess this is where time of day will come in when we take the drone images, right? Because you'll need the sun on the weeds as well, right? To be able to, if they're in a shadow, it'll be difficult to pinpoint them. Is that?
Yeah. So that's why we're planning to like take it at like 12 in the like prime time of the sun, and trying to make sure we get kind of like the similar like when we take the images and stuff is kind of along the lines at the same time. For now, at least, I guess we could look at maybe varying, but generally, I think that like from what I've seen, like most research papers, they try and keep it around like the same kind of like time and day and everything.
Yeah. Okay.